Hi everybody, today we're going to talk about reference angles. Reference angles will allow us to find trig values in any quadrant. So far, all of our triangles and trig functions have had positive values. We could easily put these triangles into the first quadrant. Let's look at how we can calculate trig values in other quadrants. A reference angle is formed by the x-axis and the terminal side of an angle. Remember, when we find trig values, we always do this using a right angle. Looking at the given angle, we don't have a right angle to reference. By drawing in a dashed line that touches the x-axis, we can form a right angle. Notice we have two angles here to look at. We have our original given angle, but now we have a new angle theta that we'll call our reference angle. We use this angle theta to find our trig ratios. To look at this a little more closely, I'm going to use this Geoder activity that I will include the link for. Notice I can move the point around. In quadrant 1, the given angle is equal to the reference angle. As we move to quadrant 2, you can see the reference angle appear and they look supplementary. We can move into quadrant 3 and quadrant 4 and see that we always have a reference angle to go along with our given value. The sign of trig values will not always be positive. Let's go through a few examples to see how to calculate the sign values and add the correct sign. We'll start with beta is equal to 120 degrees. I'm going to start by drawing my reference angle. I know that we're at 90 here, so I need to go about 30 over, and this will just be kind of estimated. So this, we will say, is 120 degrees. I'm going to drop down to the x-axis and say then that my reference angle would be 60 degrees. We've talked about special triangles before. Specifically, we talked about 30, 60, 90 triangles. If we say that my drawing is not at all to scale and that this radius is equal to 1, then we can talk about the sine of 60 being the square root of 3 over 2. Then we know the cosine of 60 is equal to 1/2. The biggest difference we want to pay attention to right now is where we're located on the xy plane. When I look at sine, it's positive because it's going up. But when I look at cosine, it's negative. So sine of 120 degrees will be positive square root of 3 over 2. Cosine of 120 will be a negative 1/2. And then tangent, being sine, square root of 3 over 2, divided by cosine, which is negative 1/2. This tells me I'll have square root of 3 over 2 times negative 2 over 1, which is negative square root of 3. Let's try alpha as 7 pi over 4. 7 pi over 4 would be in the fourth quadrant. So all the way around would be 7 pi over 4. Forming our reference angle, we get pi over 4. Reference angles are always positive. So even though this pi over 4 is equal to negative pi over 4, because it's a reference angle, by definition, it's going to be a positive value. Pi over 4 is our 45, 45, 90 triangle. In this special triangle, sine and cosine are equal, and they're the square root of 2 over 2. So I'll write the square root of 2 over 2, and we'll write the square root of 2 over 2. What we have to watch for, though, is the quadrant that we're in. This time we're in quadrant 4. In quadrant 4, sine is going to be negative, so this is negative square root of 2 over 2. Let's put that in our answer. Cosine is positive square root of 2 over 2. Tangent is the ratio of sine to cosine, so negative square root of 2 over 2 divided by positive square root of 2 over 2 gives us negative 1. It's often helpful to know the positive trig functions by quadrant. It might be easier to remember that using the mnemonic device, all students take calculus. A is still all, students is sine, take is tangent, and calculus stands for cosine. Let's try this example. If cosine t is 5 over 8 and t is in the fourth quadrant, we want to find sine t. So we're going to draw in a reference angle. It's not going to be perfect, but it'll give us some idea of what we're doing. Cosine is the adjacent, so let's write 5, over the hypotenuse, 8. And because we don't know this value, let's call it x. When we have a right triangle and we don't know one of the sides, we can use the Pythagorean theorem to find the missing side. This says that x squared plus 5 squared is going to be 8 squared. X squared plus 25 will be equal to 64. This says x squared is 64 minus 25, which is 39. This says x is equal to the square root of 39. Because we're in the fourth quadrant, this 39 is a negative value. when we find the sine of t, it's going to be negative the square root of 39 over 8. We don't want to put this in our calculator. We want to leave it as an exact value. Let's give that another try. This time I have sine t is negative 1 over 8, and t is in the third quadrant. We want to find the tangent of t. So in the third quadrant, I draw a reference angle. Sine is opposite. We'll put negative 1. Hypotenuse is 8. This time we don't know the adjacent. Again, we'll call it x. Using the Pythagorean theorem, we have negative 1 squared plus x squared is equal to 8 squared. This is 1 plus x squared is 64. X squared is 63. When I take the square root, we get that x is equal to the square root of 63. 63 is equal to 9 times 7. Because I can extract the 9, I can make this x is equal to 3 square root of 7. So when I can reduce the radical, I always will. When we go to put 3 square root of 7 back into our triangle, we want to look at where it's located. In the third quadrant, cosine is going to be negative, so I have negative 3 square root of 7. Tangent of t is going to be the opposite, negative 1, over the adjacent negative 3 square root of 7. The negatives cancel, so now I have a positive. I don't like the square root of 7 in the denominator, so I multiply by the square root of 7 over the square root of 7. 1 times the square root of 7 is the square root of 7. Keep the 3. Square root of 7 times square root of 7 is a 7. So my solution is the square root of 7 over 21. Notice our answer is positive, but that matches what we said earlier, that we have all in the first quadrant, sine in the second quadrant, tangent in the third quadrant, and then cosine in the fourth quadrant as being positive. So let's quickly talk about domain and range, and I'm mostly going to look at sine and cosine right now. Hopefully you see that as we're finding sine and cosine, we can do that for any angle. It doesn't matter if it's positive or negative, which means the domain for sine or for cosine would be negative infinity to infinity. As we find these values, we're dividing either the opposite or the adjacent by the hypotenuse. The hypotenuse is always the biggest side in a triangle. This means that we are limiting how large or how small our ratio can be. The biggest the ratio could be is at 1, and that happens at an axis, maybe 0, maybe pi over 2. The smallest it could ever be would be negative 1. Think back to looking at pi or 3 pi over 2. So this says our range for sine and cosine is negative 1 to 1 inclusively. Tangent is a little bit harder because tangent is sometimes undefined. It's undefined anytime the cosine of t is equal to 0, and we'll come back and talk about this more in coming videos. To finish off our talk today, let's find some trig values for things that don't fall into the 30, 60, 90 or 45, 45, 90 triangle. This means you're going to grab your calculator. Anytime you use your calculator to find trig values, make sure you're on the right setting. Pay attention to when you're in degrees and when you're in radians. So our first one says cosine of 208 degrees. So before I start, I'm going to check my settings, put it in degrees, then I can say cosine of 208. It says negative 0.8829. I'm going to call it negative 0.883. Next, I have sine of 3 pi over 5. Having the pi included tells me that I'm in radians. So back in my calculator, I go to the settings, I change to radians. Now I can type sine of 3 pi over 5. It says 0.951. The last one says tangent of 8, and the first thing I want you to do is really look at this 8. It doesn't have a pi, but it also doesn't have a degree symbol. Missing the degree symbol is our biggest clue. This tells us that 8 is in radians. We're still in radians from our last problem, so now I'm going to put in tangent of 8. It says negative 6.7997. I'm going to call that negative 6.8. As you're working on these problems, I think it's a good idea to draw whenever necessary. So as you're looking at reference angles, drawing a little XY coordinate system and going to the correct quadrant will help you with the sign of the value. If you want to check things with your calculator, I think that's a great idea. Technology is a great aid, and I do encourage you to use it. Unfortunately, it won't work for all problems, so it's important for you to understand the steps and to know the relationships between the angles and the trig functions.